The aim of the Glacsweb project is to use the latest technology to understand how glaciers respond to climate change. This study takes place in Iceland and brings together the expertise of geography, electronics and computer science. The team stay in a house where we can set up a laboratory and carry out final checks, unpack all the equipment and do some tests.
Somewhere. I'm sure we could find things.
I was thinking some music. Yeah?
The drive up to the glacier each day is about 16 kilometers long, and here we pass the bridge where we have a camera studying the river, taking measurements. Towards the top you can see across the main ice cap, which stretches for a further 50 kilometers.
And they're just eating some jelly dodgers. Get off them.
Where we stop, we can look down on our equipment which has survived the long, hard winter. The first days are occupied mapping out the glacier, repairing broken equipment, and also carrying out a radar survey, which gives us a map of the features underneath the ice and the depth of the ice. Meanwhile, back in the laboratory, final tests and checks are carried out on all the equipment to make sure it's ready for deployment.
Oh. Changed a lot. Fantastic.
Yeah, thank you. Oh, they don't very.
The geophone nodes, which would detect very small movements, are finally sealed up. And final tests are carried out on the glacier itself.
Right schedule to wake up at 12 o'clock every day.
Yeah. Okay.
Glacier Jeeps drives our equipment onto the glacier. This includes a hot water drill, which we use to cut holes to the bottom of the glacier to deploy the equipment. It takes melted water from the surface of the glacier, heats it up and pumps it down the pipe at high pressure, and this is used bouncing on the surface until we reach the very bottom. This takes about 20 minutes, and you can feel when you hit the bottom when the pipe barely moves any further. Extremely accurate GPS units are also used on the surface to measure the flow rate of the ice. On the final probe deployment day, the probes are double checked and then sealed up very carefully so that they are watertight enough to survive under the ice. The computers in the base station are prepared to communicate with all the equipment and sensors. These probes contain sensors which measure temperature, pressure, the orientation of the case, and the case strain. And all these readings are radioed up to the surface systems.
2, 1. Shall you stop it? If you remember.
31. 31 is making its
I really don't like
slow
bubbles.
descent.
Go.
We can use a camera to actually go down the hole to make sure that the probe has reached the bottom of the glacier and to make sure it hasn't lodged in the side of a crevasse. After final checks, the systems are wrapped up, sealed, and left for the entire year to gather the data and send it back to our servers.